Hi everyone, welcome to Educon Community Java interview series. So today we will discuss about the Java memory model. So as you know, this is one of the important and very favorite topics for Java interviews. So today we will deep dive into it. Okay. So let's start. So basically, the Java memory model means the main primary part is like the heap memory. Okay, in Java this is divided into two major regions. So one region is known as the young region, or the new generations, like which is the young generations, and another one is the old generation or the tenured generations. Okay, so like this is the diagram. So if you will see here, so this is the young gen, or like this is denoted as XMN, and the old memories like this one. So in these young generations, like Eden space is there, then S0, S1, these things are there. So you can see here in the JVM heap. Okay, and one thing is there which is parm. So parm also, this is for now it's known as the meta space. I will discuss those things. So like this is the minor GC, this is the major GC. Okay, so we will discuss in detail, right? So first one is young generations. So this is where the newly created objects are first allocated memory here. So whenever you will create new objects, so those things will be allocated in this memory. So in the young generation part or the new generations part, and it is designed for the short-lived objects, as most objects become garbage quickly. So whenever that object will be not required, the garbage collections will be happened. So that's why like those are the short-lived objects. Okay. The young generation is further divided into two space, whatever I have told you here. So you can see here till this part to this part, total part is young generations. But we are divided this young generation into again two parts. One is Eden space and another one is S0 and this one. Okay. So Eden space is like all the new objects are first allocated here. And if an object survives a minor GC, like minor garbage collections, then it moves to the survivor space. Okay. And what is survivor space? Means S0 and S1. This is known as the survivor space. Two small memory areas that temporarily hold the object surviving previous collections. Okay. So first, the newly created objects will be stored where? In the young generations. In the young generations, Eden space. Okay. So Eden space is the primary area where the newly created objects will be stored. Right. So usually we tell like objects when you will create, those will be stored in the heap memory. But inside heap memory where? Like we are deep diving into it. Okay, so inside the heap memory there is young generation part, and inside it Eden space is there. So whenever the minor GC will be done, then it will be go to the it will go to the survivor space. Okay, which is S0 and S1. Clear? So this young generations part is done. Okay. Now is old generation or the tenured generations. So this area stores the long-lived objects, meaning objects that have persisted through multiple GC cycles in the young generations. Means those objects are required more in your programs or in your systems. So those all passed the multiple GC cycles. Okay. So those are the long-lived objects. So those things are stored inside the old generations or the tenured generations. Okay, so it is much larger than the young generations. So this is the old memory. Okay, so now this is designed for the objects that are expected to exist for a longer durations. When this memory fills up, a major garbage collections or full GC occurs, which is more expensive in terms of performance. Okay. So whenever this old memory or old area will be totally filled up, then the major GC is a uh, more costly nature. Okay. So that will be happened, and that will basically check like which objects are using less. Okay, so those things will be happened, and if that major garbage collection cycle also passed, then uh, again it will be there inside the tenured generations. Otherwise we will be we will garbage collect those objects. Then Metaspace, the evolution of ParmGen. So before Java 8, the permanent generations or ParmGen was used to store the class metadata, intern strings, and the static variables. Class metadata, intern strings, and static variables. However, ParmGen had a fixed size, so that was the limitations of it before Java 8. Okay, so like whenever the memory totally filled up, then it was some problematic. But as it was not dynamic in nature. Okay, so that happens and like when the all the objects or all the strings or static variables are totally filled up in that area. Okay, and it causes what? Out of memory error. Okay, due to the uh, space limit issue. Okay, so from Java 8 and onwards, that ParmGen was replaced by the Metaspace, which provides the automatic expansion. So like no fixed upper limit unless configured explicitly, and more efficient memory management, like uses a native memory rather than the JVM heap. Okay, so you can see here, this is the JVM heap and this is the native memory. Okay, so where the palm is there. So earlier, earlier there was totally that palm area was inside the heap. Okay, JVM heap. But now after Java 8 onwards, that palmgen was replaced by Metaspace, and those uses the native memory. Okay, so like if we are not just configuring the like memory of it, then automatic expansion occur here. Okay, so if you want to configure the metaspace size, you can do it by using this command like java hyphen xx metaspace size. You will give the size of it. Okay, and maximum metaspace size also you can add here for your app. Okay, so we can also like according to our capability, we can also configure the size of the metaspace. Otherwise, automatic expansion will be happened if you will have more memories, right? So right, mark and sweep algorithm is one of the best known algorithm for garbage collections. So what are the main steps of it? So like marking all objects in use, okay, sweeping away unreferenced objects, and compacting memory for better allocations. Okay, next is Java provides different garbage collection implementations. So first one is serial GC. So this is basically a single threaded collector. So best for small apps running on single core CPUs. Okay, where your application is small, use case is small. So there less codes will be used, right? So there the single threaded environment, and there we can use the serial garbage collection, and it stops the entire applications during garbage collections. So making it less suitable for high performing apps. So like if one will ask you like in microservices, okay, can we use the serial GC? Obviously no, because there are multiple services will be processed, and multiple, like there will be multiple thread environment also will be there. So if all the services will be stopped, then all users will face some issues. Okay, so there we will use mainly the parallel GC, so multiple threads for garbage collections and improving the performance compared to the serial GC. However, it still pauses the app during collection. Okay. Next is garbage first GC, the default GC from Java 9 onwards, and it splits the heap into smaller regions and collects the garbage in priority order. So it reduces the pause time. So now onwards, this G1 or garbage first GC are mainly used in the market microservice applications. So like the heap, suppose this is the heap, and this heap will be divided into some smaller parts or subparts. These are the small regions, and these small regions, one by one, the garbage collections will be happened. Okay, so for that reason, whole applications will not pause. So part by part, it will pause. So it reduce the pause timings. Okay, like if to do the garbage collections for all the heaps, if it would take suppose 10 hours, suppose I am just uh, giving you one example. So like if it will be divided in some small parts, suppose this part one according to the priority queue. So this P1 part will be garbage collected, and for that, suppose it takes 30 minutes. Okay, so for the first 30 minutes, the your applications will be paused. Okay, so then again your applications will run. Then after some hours, suppose you are doing the garbage collections for part two. So again, if it will take suppose 1 hour. Okay, so in that way, part by part, we are doing the garbage collection. So pause time will not like huge. It reduce the pause times. We can also schedule in prior, like our applications will be garbage collected in that time. So in between, suppose we can give the notifications through mails or something like that, that our like some downtime will be there from 10 to 10:30. Okay, so users will be notified there. Some maintenance work is going on, so that's why your applications is stopped now. So in that way, we can efficiently do the garbage collections, and we can use our memories properly. So that's all. So if you like the content, just do like, share, and subscribe, which will motivate me. And I will discuss more topics. And if any other topics you want to discuss, like you can also comment down that topic. I will cover those topics in the next lectures. So thanks all.